So let's suppose we choose a new function called h in terms of f and g. So maybe like let us suppose choose something like f of x minus g of x. Difference because you wanted the difference in derivatives and you have a 2 also. So either you can take a 2 before this or a 2 after this. So you observe you have 2f dash c, g dash c. So you can take a 2, take a function like this. Then what is h of 0? F of 0 minus 2 times g of 0. So f of 0 is given as 2, g of 0 is given as 0. So 2 into 0. So this will be 2. And what is the value of h of 1? F of 1 minus 2 times g of 1. F of 1, you know, it is 6. G of 1, you know, it is again 2. So this also 2. So clearly you can see that h of 0 is equal to h of 1. And if f and g are continuous and differentiable, h also will be continuous and differentiable. But the third condition of Rolle's theorem is main. So if this third condition is satisfied, you can say h dash of c must be 0. H dash of c should be 0. This you cannot apply with f and g because they have not given f of 0 equal to f of 1 here. So that's why I have to choose a new function in terms of that. And h dash of c means you find the derivative for this function. What is h dash x? So what is the value of h dash x? F dash x minus 2 times g dash x by differentiating that h of x. So h dash of c minus g dash of c means f dash of c. So h dash of c means f dash of c minus 2 times g dash of c equal to 0. So clearly we'll get f dash of c is 2 times g dash of c. So fourth option is the answer. We'll move on to the next question. So C is the point at which Rolle's theorem holds for the function in 3 to 4. What is f double dash of C? So that means you can just find f dash of C and equate with 0 because it satisfies Rolle's theorem. This will help you in finding C. And that C should belong to the interval in which it satisfies Rolle's theorem. So we have to, of course, find C within that only. So what is f dash of C? So first you can write that function f of x as log of x square plus alpha minus log of 7x, which you can write log 7 and log x separately. So f dash of x, when you write down, the differentiation of log will be 1 by x square plus alpha. And differentiation of x square plus alpha is 2x by chain rule. For log 7, differentiation is 0. Log x, it is 1 by x. So this is f dash of x. So f dash of c means you will replace x with c. So 2c by c square plus alpha minus 1 by what is this x now? C. So this is equal to 0. So we'll be getting 2c by c square plus alpha equal to 1 by c. So, but to find c, you should know alpha. How do you find alpha? Whenever Rolle's theorem is satisfied in the interval, f of 3 and f of 4 must be equal. So you can also take f of 3 equal to f of 4 because Rolle's theorem is satisfied. And what does f of 3 mean? Put x equal to 3 in that. It will become logarithm to the base c, 9 plus alpha by 21. And f of 4 means logarithm to the base c, right? X as 4, you'll get 16 plus alpha by 7 into 4, 28. Both sides you have log, you can remove the log. So you'll get 9 plus alpha by 21 equal to 16 plus alpha by 28. This will help you in finding alpha. So how did I get this? I'm just using the condition that f of 3 equal to f of 4 because for Rolle's theorem to be satisfied in any interval, f of a and f of b must be equal. So from here, if you cancel out 3, 7 with 7 3 times, 7 4 times, and now cross multiply 4 into 9 plus alpha equal to 3 into 16 plus alpha. So 36 plus 4 alpha is equal to 48 plus 3 alpha. So alpha is 12. From here, alpha is 12. Put that alpha value. So 2c square will be equal to c square plus alpha. C square is equal to alpha, which is 12. So c is plus or minus root 12. So what is the value which belongs to 3 to 4? Minus root 12 does not belong to the interval. So we have to take c as plus. And after you get c value, they actually ask you have double dash of c. So we'll have to do differentiation again. So what is f dash x? We'll write again. So what is f dash x? That we got x by x square plus alpha minus 1 by x. So this was the value that we got for f dash x. So they asked us f double dash of c. So write f double dash x first. For that you need to apply quotient rule here. That is 2 into denominator into derivative of numerator. So x derivative is 1 minus numerator into derivative of denominator. X square derivative is 2x by square of denominator. And what is the derivative of 1 by x minus 1 by x square? So this is f double dash of x. So that is same as 2 times x square plus alpha minus 2x square will be alpha minus x square. And what is the value of alpha? We already got 12. So alpha you put 12, x square minus 2x square is minus x square by x square plus 12 whole square plus 1 by x square. So here we wanted to find f double dash of x value, and what is the value of x that you f double dash of c is root 12. So f double dash of c is nothing but f double dash of root 12. So put that value 2 into 12 minus, if x c is root 12, c square is 12 only. So 12 minus 12 by 12 plus 12 whole square plus 1 by x is root 12, x square is 12 because you are putting x as c here. So the first term is 0, will be left out with 1 by 12 as the answer. So this we got from f dash of c equal to 0 condition of Rolle's theorem, and this we got from f of a equal to f of b condition of Rolle's theorem. And this alpha value only we have used here to find c. And since we are checking it in 3 to 4, something which is not in the interval is ruled out. So minus root 12 is ruled out, which I have chosen root 12. And once you got c, you find double derivative and put this c value there. Yeah, then try the third problem. So here f of 0 equal to f of 1 is the condition for Rolle's theorem. So we can say there is some value c in open interval 0 to 1, so that f dash of c should be 0. And they also gave f dash of 0 is 0 separately. This is also 0. So what can you say about double derivative? So generally derivative f dash of 0 is 0. At point C, f of 0 is 0, f of 1 is also 0. The derivative is 0 at this point means maybe the graph is something like this, which can have a tangent here. But if it goes like this, f of 0 and f of 1 won't be same. So what could be the possibility? You can have something like this, f of 0 is f of 1, f dash of c is also 0 in the interval. So if it is like this, what can you say about f double dash x? In that interval, f double dash of x is also 0 when x belongs to 0 to 1. So this is a possible graph. Because f of 0, f of 1 must be same. Derivative also must be 0. If you choose like this, it will be anyway valid. So better choose it like this and conclude. So fourth option will be the answer. Because f dash x is 0, f double dash x will also be 0 when you differentiate. You can have other possibility also. I just took this as an example. So what would happen if you choose any other possibility? If the graph is something like this and something like this. Here also f of 0 and f of 1 are 0. And in between 0 and 1, the derivative is 0 at some point. Let this be some c. So can you conclude that double derivative is 0 within this interval? In the previous graph, it was easy to conclude if it is a straight line like this. Can you conclude that for this type of graph? So you can see that f dash of 0 and f dash of c both are equal. So what does it mean? Between 0 and c, double derivative will have a root. F double dash of c will become 0. If, like for example, if I name this root as c, this I'll call it as some c1. F double dash of c1 is 0, where c1 belongs to 0 to c. So because f dash is satisfying the conditions of Rolle's theorem, so therefore you can see between 0 and c some root will be there. So c1 is a root between 0 and c. And obviously 0c also is a part of 0 to 1. So this also belongs to 0 to 1. Which means between 0 to 1, the f double dash x equal to 0 has a root. This concludes that f double dash x equal to 0 has a root in 0 to 1. So even in this case, it is valid. It is not necessary that it should be like this. Only one possibility. but otherwise also it's valid. So let's move on to the next question. So all of you try the fourth one. If Rolle's theorem holds for this function, what is the ordered pair AB? So what is the first condition for Rolle's theorem? If it is valid in this interval, f of 1 equal to f of 2 we can use. Second condition, they already specified f dash of 4 by 3 is 0. So you have two unknowns and two conditions. You can easily solve and find out. So what does f of 1 give you? So if you put x as 1, f of 1 will be 1 minus a plus b minus 4, putting x equal to 1 in the function. F of 2, put x equal to, it will be 8 minus 4a plus 2b minus 4. So this will give you this 4a minus 4a and a together will become 3a. B minus 2b is minus b. And looking at the constants, so here we have 1 minus 4 minus 3. And in the right hand side, what is the constant? 8 minus 4, 4. So 3a minus b is equal to 7. So like this, what is f dash of 4 by 3? So first let us find the derivative f dash x. The derivative of x cube is 3x square minus ax square, derivative is 2ax, bx it is b, for 4 it is 0. F dash of 4 by 3 means put x as 4 by 3, you'll get 3 into 16 by 9 minus 2a into 4 by 3 plus b equal to 0. Okay, so you multiply throughout by the LCM 9, then this will be 48 minus 2 into 4, 8a into 3 again. So 24a plus 9b equal to 0. So further you can divide this with 3 if required. Otherwise I could have cancelled here. That would have been better. So just cancel this 3 times here. Then we'll have 16 minus 8a plus 3b equal to 0. Or 8a minus 3b equal to 16. So solve these equations now. That is 3a minus b is 7. And 8a minus 3b equal to 16. If you are solving these equations, you can get the value of a and solve this. So how to solve? Multiply the first equation with 3 will give you 9a minus 3b equal to 21. Write the second equation as it is. And just subtract these two. You'll get 9a minus 8a. A, b will cancel. 21 minus 16, 5. So a will be 5. And put the value of a in the first equation. So 3a minus b equal to 7. So putting a as 5, 15 minus b will be equal to 7. And therefore b is 15 minus 7, 8. So a is 5 and b is 8. So the ordered pair AB is therefore 5, 8, first option. Okay, all of you try the fifth one. So f of 0 equal to 0 is nothing but f of 0 minus 0 is 0. F of 1 equal to 1 is f of 1 minus 1 equal to 0. F of 2 equal to 2 is f of 2 minus 2 equal to 0. What do you observe from all this? In general, when I consider f of x minus x as a new function called h of x, so f of x minus x equal to 0, for this equation, x equal to 0, 1, 2 are the roots. Because when you put x as 0, h of 0 is 0. X as 1, h of 1 is 0, h of 2 is 0. From these conditions, you can clearly see that h of 0 is 0, h of 1 is 0, and h of 2 is also 0. So that means this function h of x equal to 0 has 3 roots, 0, 1, and 2. From here, you try to do the problem. So because h of 0 and h of 1 are equal, there will be one root between 0 and 1 by Rolle's theorem. And h of 1 and h of 2 are also equal. Between 1 and 2, there will be one root. So if I differentiate this and find h dash x, it will be f dash x minus 1. So since h of 0 equal to h of 1 for first part, then h of 1 equal to h of 2 second part. So clearly what do you conclude? If h of 0 equal to h of 1, h dash x equal to 0 has a root. H dash of x equal to 0 has a root in 0 to 1. Has a root in 0 to 1. Similarly, this means h dash x equal to 0 has a root in 1 to 2. Has a root in 1 to 2. And h dash x equal to 0 means f dash x equal to 1. Okay, so this we can conclude. Then since you want to conclude something about double derivative, what is h dash of 0? You find out h dash of 0 is f dash of 0 minus 1. Did they give f dash of 0 value? We don't know what is f dash of 0 here. Okay, so how will you conclude about double derivative? So just what we can do, if you randomly draw the graph for h of x, so between 0 and 1, it will have a root. So that means the graph of h of x, if you draw, it is having one root between 0 and 1 and another root between 1 and 2. Then what can you say about double derivative? If I mark 0, 1, 2 here. So if h of 0 and h of 1 are 0, what does it mean? Between these two, the function will have one root. Between 1 and 2, it will have some root. It's a random graph, not accurate graph. So h dash x is 0, once here and once here. Then what can I say about double derivative? Can it have a root between these two? So where will the root of h double dash x equals 0 lie? H double dash x equals 0 will have a root between the roots of h dash x equal to 0. Just like, suppose if h of x equal to 0 has some roots alpha, beta, gamma, h dash x equal to 0 will have a root, one root between this c1, another root between this some c2. And h double dash x equal to 0 will have a root between these two some c3. So therefore you can conclude that in the interval h double dash x equal to 0 will have a root. Using this logic. So is this? So let's start with question number 6. F and G are two twice differentiable even functions on their interval. And some values of the function are given. We have to find out the minimum number of roots of this equation. So if you carefully observe this equation, so this can be written as d by dx of f of x into g dash x. So when you apply uv for this, you will get f of x g double dash x plus f dash x g dash x. So when you apply d by dx of uv for this function, you are going to get this result. So this is nothing but d by dx of this function is equal to 0. So let us start with assuming a function h of x called f of x into g dash x. And what does this condition mean? H dash x equal to 0 in minus 2 to 2. So you represent this as d by dx of this. And if you name this function as h, the derivative of that is nothing but h dash x. So that is equal to 0 in minus 2 to 2 has how many roots? So h dash x equal to 0 has how many roots is the question here. So try this now. And they gave some criteria, f and g are even. You can use that criteria. F is even, g is even. They have specified already. You can also use this. So we have f of 1 by 4 is given as 0. F of 1 by 2 is given as 0. Then f of 1 is given as 1. G of 3 by 4 is given as 0. So since it is even function, f of minus 1 by 4 is same as f of 1 by 4. So these two are 0. And also f of half is same as f of minus half. So this is 0 and this is also 0. So if this condition of Rolle's theorem is satisfied, what do you conclude? F dash x equal to 0 has at least one root. It has at least one root in which interval? Minus 1 by 4 to 1 by 4. Because this is like f of a equal to f of b. So then the derivative will have at least one root in the interval. And this means f dash x equal to 0 has at least one root. This has at least one root in minus 1 by 2 to 1 by 2. Okay, so if I just show on the number line, so you'll have say minus half here, minus 1 by 4 here, and 1 by 4 here. Minus 2 and 2 are here. So between minus 1 by 4 and 1 by 4, it has a root. So between minus 1 by 4 and 1 by 4, it has a root. So in this, there is one root. Minus 1 by 2 to 1 by 2, there is one root. So what else you can conclude? G of 3 by 4, they gave 0. So G of minus 3 by 4 will be same as G of 3 by 4 anyway. So that means you can also say G dash also will have a root. G dash x equal to 0 has a root in minus 3 by 4 to 3 by 4. So at least how many roots will be there now? So these 4 are equal means we have f of minus 1 by 4, f of 1 by 4, f of minus half, f of half. All these are equal. So you can have a root between minus 1 by 4 to 1 by 4, 1 by 4 to 1 by 2, minus 1 by 2 to 1 by 2 also. So you can have one root here, one root here, one root for this interval. Because what does the Rolle's theorem state? If f of a equal to f of b, so f dash of x equal to 0 has a root in open interval ab. So according to this, what do you conclude? So if f of minus 1 by 4 and f of 1 by 4 are equal, f of x will have a root between them. Similarly, if these two are equal, it has a root in their interval. These two are equal, there is a root in their interval. Like that, you can have 3 roots. Okay. And apart from that, this will have at least one root. So you can now say that f dash x equal to 0 has at least one root. How many roots? Has at least 3 roots, sorry. 3 roots. And g dash x equal to 0 has at least one root. So what can you say about their product? But they're asking about h dash x. So what do you conclude? So they're asking about this function. So what will you conclude about number of roots for h of x? So I conclude about f of x or f dash x. So for g, I conclude about which condition? Because if g of a equal to g of b, g dash x will have a root. So I'm talking about f dash x into g dash x here. So 4 roots if I have to write, f dash x into g dash x has 4 roots. At least 4 roots. But there the function doesn't have f dash x, it is just f of x into g dash x. So probably in the question, it could be something like f dash x, f double dash x. Then it will be correct. So then this will be d by dx of f dash x into g dash x. Then your answer will match. So f dash x into g dash x has at least 4 roots. So probably this should be f dash x. Then it will hold. So they gave the answer 4. So if it is f dash x here, then it will hold. And this is f double dash x. Then this will become d by dx of f dash x into g dash x. So h of x will take along with this dash. Because anyway, all the 4 are equal. So not only these two cases, you have other cases. So I showed here. So between these two, one root, between these two, one root, between these two, one root. So there are at least 3 roots. And for g of 3 by 4, 0 and g of minus 3 by 4 is same as g of 3 by 4. There is one root in that interval also. So including this, here there are minimum 3 roots. Here there is minimum 1 root. Overall, it has minimum 4 roots. So these are based on Lagrange's theorem. The value of C of Lagrange's theorem is. So for Lagrange's theorem, what are the criteria? F dash of C equal to f of b minus f of a by b minus a. You have to use this to find C. So what is f dash x? We'll write first. The differentiation of x cube is 3x square minus for 4x square it is 8x and for 8x it is 8, 11 it will be 0. This is the differentiation is 3x square minus 8x plus 8 and then f of 0 and f of 1 if you find out f of 0 will be 11 and f of 1 if you find out it will be put x as 1 minus 4 plus 8 plus 11. So what is this? 16. So according to Lagrange's theorem, f dash of C should be equal to f of b minus f of a by b minus a. So A and B are here 0 and 1. So f of 1 minus f of 0 by 1 minus 0 is f dash of C. That is, what does f dash of C mean? Put x as C here and write 3c square minus 8c plus 8 equal to f of 1 minus f of 0 is nothing but 16 minus 11 by 1 minus 0. That is 5. So 3c square minus 8c plus 8 is equal to 5. So plus 3 equal to 0. Solve this to find C. So minus b plus or minus root of b square minus 4ac by 2a. So use this. Then 8 plus or minus root of 64 minus 36. 28 by 2 into 3. So here you can just cancel with 2 and write the answer. This is 4 plus or minus root 28 is 2 root 7. So root 7 would remain by 3. And what is the value which lies in the interval? I think C, because this should also belong to 0 to 1. C should belong to 0 to 1. So therefore, C will be 4 minus root 7 by 3. Other value will exceed that. You can discard it. So out of the two values, we'll choose this one, 4 minus root 7 by 3. So this is just direct formula application only. It's very easy. So I'll show the next question. You can try this now. Okay, so they said that it is continuous and differentiable. So Lagrange's theorem can be used here. So if I apply for minus 7 to 0, for example, if I apply Lagrange's theorem, but they gave f dash x less than or equal to 2. So what is f dash of x by Lagrange's theorem? F dash of x or f dash of c is f of b minus f of a by b minus a. It should be less than or equal to 2. So use this condition. Then f of 0 we have to find. What about f of minus 7? It's minus 3. So this will become plus 3 by minus 7 less than or equal to 2. So when you multiply with minus 7, inequality will reverse and we'll get f of 0 plus 3 is greater than or equal to minus 14. F of 0 is greater than or equal to minus 17. What was f of minus 7 given as minus 3? No, this became plus 3. And the other side you have minus 14. So is this correct? F of 0 greater than or equal to minus 17. So for minus 7 to 0, I applied Lagrange's theorem and wrote f dash x equal to f of b minus f of a by b minus a. So I have to write 0 minus 7 in denominator actually, because b is 0. So then b 0 minus of minus 7 would become 7. So that means this is just 14. If that is 14, what would you get here then? F of 0 is less than or equal to, this will be less than or equal to 1. Inequality won't reverse because this positive won't be. Less than or equal to 11. Similarly, if you want to find f of minus 1 should be involved in the theorem. So they could have given minus 7 to 1 here. They have given minus 7 to 0. So if you apply Lagrange's theorem for minus 7 to 1 interval, so for this interval, if you are applying Lagrange's theorem, so what do you write? F dash x equal to f of 1 minus f of minus 7 by 1 minus of minus 7, that is less than or equal to 2. So in the question, they should have specified the interval as minus 7 to 1 instead of just giving 0 because you wanted f of 1 also. So f of 1 minus of minus 3 less than or equal to, here we'll get 16. F of 1 less than or equal to 13. So we already got f of 0 less than or equal to 11 and f of 0 is less than or equal to 13. What is the value you are getting? Let me check. This is 1 plus 7, 8 only. 8 into 2, 16. 16 and that was 3. So 13. So what can you say about f of 0 plus f of 1? So we got f of 0 less than or equal to 11. F of 1 less than or equal to 13. So the sum of these two is what you wanted. F of minus 1 plus f of 0. So it's not 1, it is minus 1. Okay. Then if it is minus 1, the answer will be taken according to that. So let us take minus 1 here then. So then the denominator will become, in this case, so they ask for minus 1, not for 1. So when you apply for minus 7 to minus 1, then they need not specify because it's a part of 0 only. So f of -1 minus f of -7 by -1 minus of -7 less than or equal to 2. So f of -1 we don't know. F of -7 is -3. So this will become +3. In the denominator, we'll get 6. So less than or equal to 12. So f of -1 is less than or equal to 12 minus 3. That is 9. And we already had f of 0 less than or equal to 11. Now we got f of -1 less than or equal to 9. So the sum of these two is therefore less than or equal to 20. So which option will satisfy? Fourth one. So this is the answer. So because if it is 1, f of 1 here, I could have given -7 to 1. -1 is a part of this, so no problem. So we can apply Lagrange's theorem for -7 to 0 one time and -7 to -1 one time, so that you can involve these two separately and then add them.